Good afternoon, students. Today we are going to study the R and S configurations. हम जो है R और S configuration आज डिटेल में स्टडी करने वाले हैं. इन R और S configuration के अंदर सीक्वेंसिंग रूल बहुत इम्पोर्टेंट है. सीक्वेंसिंग डिसाइड करने के लिए हमको जो है जो कार्बन आइटम से वो 4 डिफरेंट ग्रुप से अटैच होना चाहिए और जो 4 डिफरेंट ग्रुप अटैच है उनका अरेंज करना है अकॉर्डिंग टू द एटॉमिक नंबर्स. और जैसा एटॉमिक नंबर्स बढ़ेगा वैसा ही उसका प्रायोरिटी बढ़ते जाएंगी. सो द 4 ग्रुप्स अटैच टू द स्ट्रेटोजेनिक सेंटर्स आर अरेंज इन द सीक्वेंस इन द डिक्रीजिंग ऑर्डर ऑफ द atomic number of atoms directly attached to the strogenic centers. The atoms of the highest priority is given to the highest atomic number. इस तरह से इसके एग्जांपल्स स्टडी के लिए दिए गए हैं. एग्जांपल्स के अंदर डिसाइड किया गया है ऑन द बेसिस ऑफ सीक्वेंस, उसका रूल्स के हिसाब से. वो सारी चीज़ें हम डिटेल में स्टडी करेंगे in the given videos.
How to assign Rnds configuration. What is configuration? Configuration is the arrangement of the groups in the space. Suppose let us take a structure like this, and here the central carbon is attached to one of the groups CH3 and another group is CH3. Since the two groups are similar, now this carbon is not the stereoactive center. Therefore, this structure will have only one configuration within the space. But at the same time, if you take another structure like this, here all the groups attached to the central carbon are different. Therefore, this carbon is stereoactive center. Since this carbon is stereoactive, now this compound can have two configurations. Suppose this is one of the configuration, and it will have its mirror image, which is having the opposite configuration. And here again the carbon is the stereoactive center. Now these two structures are mirror images of each other, and it is very easy to say that they are mirror images. But how can we label these compounds? Well, the first compound is having R configuration or S configuration. So in this video, but how we can represent these structures on the plain paper. So one of the projection is like this. Here we can observe one horizontal line and one vertical line to which all the 4 groups are attached. The intersection of horizontal and vertical line indicates the carbon, and this carbon being attached to the 4 different groups, it acts as a stereoactive center. And this type of projection we call Fischer projection. So according to the Fischer projection, the groups attached by horizontal line are above the plane, and the groups attached by vertical line are below the plane. That means according to the Fischer projection, there is no group within the plane. 2 groups are above the plane and 2 groups are below the plane. Now let us have another projection. In this projection, we can observe that one of the group is attached by a solid wedge and another group is attached by a broken wedge. So this type of projection we call the wedge and dash projection. In this, the chlorine group is attached by a solid wedge, which indicates the chlorine group is towards the viewer, and the hydrogen which is attached by dashed line is away from the viewer, and the other groups like the CH3 and NH2 which are attached by the line are within the plane. So according to this projection, one of the group is towards the viewer and another group is away from the viewer, and 2 other groups are within the plane. We can use any of these 2 projections in order to indicate the stereoactivity of the compounds. So in this video, we will see how we can assign the Rnds configuration, either Fischer projection or wedge having Fischer projection. Here the stereoactive center is attached to the 4 different groups. In assigning the Rnds configuration, we have to give the priority order to the groups attached to the stereoactive center. So OH group is attached by oxygen, NH2 group is attached by nitrogen, CH3 group is attached by carbon, and finally hydrogen is attached to the stereoactive center. Here priority order is given based on the highest atomic number. Higher the atomic number, higher the priority. Since oxygen is having the more atomic number, we should give the priority to the oxygen. So that is the first priority, and then the nitrogen, then the carbon, and finally to the hydrogen. So in this way, the first step of the Rnds configuration is to assign the priority order based on the higher atomic number. But here, before going to assign the Rnds configuration, we have to check that the lowest priority group should be on the vertical line. Here the hydrogen is given the lowest priority by the number 4, which is on the horizontal line. It is not on the vertical line. So in order to bring the lowest priority group onto the vertical line, we can make parallel transitions. By making the parallel transitions, the structure will not change, but what are the groups attached at the horizontal and vertical lines are interchanged. So by doing these parallel transitions, we can observe the structure like this. So here OH and NH2 are replacing their positions, and hydrogen and CH3 is again replacing their positions. Now again, if we give the priority order, nitrogen is second, oxygen is first, CH3 is third, and hydrogen is fourth. So now the lowest priority group, hydrogen, is on the vertical line. Now we can assign the Rnds nomenclature. We have to travel from the priority groups from 1 to 2 to 3. So when we travel like this, if this traveling direction gives the clockwise direction, it will be R configuration. If it gives anti-clockwise direction, it is S configuration. So in this structure, when we are going to travel from 1 to 2 to 3, group should be on the vertical line. If it is not on the vertical line, we can make a parallel transition such that we can bring the lowest priority group to the vertical line. Let us go with another example. Now we are going to take the wedge and dash line projection. Here again, the stereoactive center is attached to the 4 different groups. So one is the oxygen of the OH, and another one is the hydrogen, and another one is the chlorine, and the fourth one is the carbon of the carboxylic acid. Now again, we have to check which atom is having the higher atomic number. Chlorine is having the higher atomic number, so we should give the preference 1, and then the oxygen, so 2, then the carbon 3, then hydrogen 4. So in this way, we have given the priority order to the 4 different groups. Then, just like the Fisher projection, before going to assign the Rnds configuration, we have to check that the lowest priority group should be on the dash line. So in this structure, the lowest priority group hydrogen is on the dash line. We can go forward to assign the Rnds configuration. Now we have to travel from 1 to 2 to 3. And here you can observe that while we are going to travel from 1 to 2 to 3, we have jumped through the 4. So here we have to remember that while we are going to travel from 1 to 2 to 3, we can skip the 4 in between them. Now this direction is the again anti-clockwise direction. So configuration is the S configuration. So while we are giving the Rnds configuration to the solid wedge and dash line, after giving the priority order, we have to check that the lowest priority group is on the dash line. Let us take another example. Now again we have taken the solid wedge and dash line projection. Here stereoactive center is again attached to the 4 different groups. So one is the carbon of the CH2 CH3, and there is the carbon of the CH3, and the one is the bromine, and final one is the carbon of CHO. So again the priority order based on the higher atomic number. Bromine is having the higher atomic number, so it should be given preference 1. In all the remaining groups, the carbon is attached to the stereoactive center. Then how can we assign the priority order? So when we are unable to determine the priority order by the first atom, we have to go with the further atoms attached. So suppose here in the CH3, this carbon is attached to the 3 hydrogens, so we can write like H, H, H. That means carbon is attached to the 3 hydrogens. In the CH2 CH3, the carbon is attached to the 2 hydrogens and 1 carbon. But we have to arrange in the order of the atomic number. So carbon, hydrogen, hydrogen. Now this carbon is further attached to 1 carbon and 2 hydrogens. Then what about the third group, CHO? CHO is the aldehyde which is having the carbonyl group. In this carbonyl group, the carbon is attached to the hydrogen by single bond and oxygen by double bond. So it is not attached to the 3 atoms, but it is attached to the only 2 atoms because of the pi bond. Then we can assume that the carbonyl group is attached to the 2 single bonds, so we can represent the structure like this. Now this carbon is attached to the 2 oxygen atoms by single bond and 1 hydrogen atom by again single bond. So totally what are the atoms attached to this carbon is the oxygen, oxygen and hydrogen. Here we are assuming that the carbon of the carbonyl group is attached to the oxygens by two single bonds. So it is a hypothetical case which we are going to use to assign the priority order only. Now if we consider the atoms attached, so here in the CHO it is OOH, and in the CH2CH3 it is carbon, hydrogen, hydrogen, and the CH3 it is hydrogen, hydrogen, hydrogen. Since oxygen is having the more atomic number, so we have to give the second priority to the CHO, and third priority to the CH2CH3, and fourth priority to the CH3. So in this way we can assign the priority based on the further atoms attached. Now we have to check what is the lowest priority group. So here the lowest priority group is the CH3. The lowest priority group is here attached with the solid wedge. It is not present on the dashed line. So we cannot assign the Rnds configuration as it is, and we have to make that the CH3 group is attached to the dashed line. So how can we do that? Now this is the structure we are discussing, and if this structure is having a single transition instead of the parallel transition, only two groups are interchanged. What happens? When only two groups are interchanged, it can give a configuration like this, and this is a different structure. And these two structures are not equivalent because we have made only single transitions, but they are mirror image of each other. In the second structure, we can easily assign the priority because the lowest priority group CH3 is on the dashed line. So if the mirror image of the given structure is S configuration, then the original structure will be R configuration. If the mirror image of the structure is R configuration, then the original structure will be S configuration. In this way, we can go for a retro method such that we are going to assign the Rnds configuration to its mirror image, and if its mirror image is having the S configuration, the original compound will have R configuration. Or if it is having R configuration, the original compound will have S configuration. Now let us go with the mirror image of the given structure. So here already we have discussed the priority order. Bromine is the first, CHO is second, and CH2CH3 is third, and CH3 is fourth. Now here the lowest priority group is on the dashed line, so we can continue with the Rnds configuration. So we have to travel from 1 to 2 to 3. So when we travel like this, we are getting the clockwise direction. So since it is a clockwise direction, it is the R configuration. Now what about the original compound? Since the mirror image is giving R configuration, the original structure will have S configuration. In this way, we can easily assign the configuration of the compound. So the original compound what we are discussing is having S configuration.